Hey everyone, happy Friday. Today is the last day of the Remars conference. Hope you all had some amazing learning sessions. Before we dive into the topic where we'll be talking about A/B testing for ML systems, let's have a little pop quiz. Who here needs a cup of coffee to get their day started? Raise your hands. All right, a lot of coffee fans here. So today we are going to be talking about A/B testing for an ML system. The concept of A/B testing itself is not new. You might have heard about it and even instrumented it for their application. But what is new is over the past few years, our systems have evolved from being monolith to incorporating more and more of machine learning features and services. So in this talk, we'll be focusing on how we implemented A/B testing for a real-world ML system. I'm Riaz Liaquat. I'm a product manager at Amazon. Joining me is my colleague Anu.
Hey everyone, my name is Anu Jayanti. I'm the solutions architect at AWS. For the first part of the session, Riaz is going to walk us through a use case which provides how the recommendation engine helps the startups. I'll come back for the second part and then we will go over why ML models change, how those changes are tested in real time, and then even cover about the best practices that we use in our project, and then do a little bit deep dive into A/B testing. Back to Riaz for now.
Thank you, Anu. What is one of the main challenges that we had during the pandemic while trying to watch shows? It takes an enormous amount of time to discover content, and one of the ways to solve this problem and to improve customer experience is to use machine learning and personalization. So in today's example, we are not going to be focusing on the Amazon Prime Video use case, but we are going to be talking about how machine learning and personalization can help to address challenges faced by startups when they are trying to build on AWS. So we spoke to hundreds of startups and first try to understand that when they want to build on AWS, what are some of the challenges that they are facing. So AWS has like more than 200 plus services. We have like great breadth and depth to offer like many different services. But with that comes also complexity, and that's why we want to understand like what exactly are the challenges that our startups are facing before we solve them. The first one, as I mentioned, is definitely around using what technical service. For example, like if startup customers are using EC2 or ECS, the question should be like, should we also use like API gateway? Should we use a service like Cognito, for example? So having like that type of recommendation is certainly valuable to a startup. The second thing is AWS billing. So as I mentioned, AWS has like 200 plus services. And with that, sometimes the challenge is also to understand the billing and cost of each of those services. So having more granularity and understanding around the billing and how to keep the cost low, I think that is a second thing that we heard. And the third thing is at AWS, we produce a high number of technical content. But if I am a founder or a CTO of an early stage startup, sometimes I just want to sometimes I want an easier way to discover this content. And discovery is certainly a challenge when it comes to technical content. So that's the third one. So let's dive a little bit deeper to understand what right guidance at the right time, because I think it's a very tough question to answer. So here first is a startup itself is a pretty broad term. It could refer to a 2-person startup working out of a garage. It could also refer to a billion-dollar unicorn as well. So I would say we're early on in the life cycle of a startup. So usually what matters to startups is mostly funding and credits, because they need to leverage this to build out their MVP. Once they have their MVP built out, then they can take this to investors to get additional round of funding. So when a startup gets seed funding or early stage funding, so then what becomes important to them is product market fit. So this is where AWS, we can provide not only technical guidance, we also have co-founders within our organization who can connect the startups with the right VCs and accelerators. As the startup continues to grow, scaling becomes important. So this is where making a lot of architectural decisions. Should they be using a data lake? Should they be using an analytics service like QuickSight? So those kind of decisions and how it impacts their product roadmap, that becomes important. And the last stage is once a startup has, is generating millions of revenue and has like $1 billion valuation, all they care about is deploying into other regions and then catering to different market segments. So to go back and answer this question, so what does right guidance at the right time mean? I would say like it really depends on the maturity level of the startup and how we can provide personalized recommendations based on their life cycle. So in order to solve the challenges faced by startups, AWS designed this program called as AWS Activate. So what is AWS Activate? AWS Activate is a program launched to empower startups with funding as well as technical and business guidance so that they can successfully launch on AWS. There are several benefits to using Activates. Some of the key ones that I want to highlight today are, so one, startups can get access to up to like $100,000 of credit. So if you are like a startup founder, you can definitely reach out to us for like getting access to this funding. The second thing is, like as I mentioned, like getting technical guidance and support, understanding what architectural patterns to use, so we can definitely provide that guidance. The third thing is like if startups want to successfully build on AWS, it's important to have the cloud knowledge within their organization, so they can also leverage credits and funding to build cloud knowledge within their organization as well. And the fourth thing is we also work with a lot of third-party partners who have like special offers and discounts, like Neuralink, Datadog. So we can also pass those discounts and savings to startups so that they can take advantage of it when they build a technical stack. And the last one is getting personalized guidance through the Activate Console, which is what we'll be talking about today. So before we dive into the Activate Console and understand the personalized guidance, so I want to highlight a couple of startups who have been part of Activate. And the first one I want to talk about is Stripe. You might have heard about Stripe. Stripe provides API-based services for financial transaction automation. They enrolled as an early member of the Activate cohort, and they gradually grew to become like $1 billion unicorn. But what is fascinating about this growth is they not only grew, but they also launched products such as Stripe Atlas, which actually helps like other startups build on AWS as well. So this essentially helped to launch additional growth to other startups within the community. The other startup who have been highly successful as part of Activate is Airbnb. I'm sure like all of us would have used Airbnb while we are on vacation. I'm a huge fan of Airbnb. Airbnb, I guess, started as a very small team. So initially they're just like using like some of very few services like Amazon EC2. But over the years they grew to adopt many of our managed services such as RDS, EMR, and so on. But since they adopted a lot of managed services, they were able to reduce operational inefficiencies within their organization. And this helped them to innovate faster on behalf of the customer. So we saw a couple of highly successful startups. Now the question is, how do we help the next wave of startups? So as I mentioned earlier, Activate was one of the programs designed to help startups. And in this slide, I want to talk a little bit deeper on how Activate actually helps customers. The first thing that we want to understand before helping startup customers is to understand their profile. So we want to understand like what industries a startup is part of. Are they part of like autonomous driving? Are they a health and life sciences startup? What is their level of funding? Like what is their tech interest? Like for example, if they are interested in analytics, like something like S3, Amazon QuickSet, all these type of analytics services would definitely be helpful for them. So as we collect more of this information, it becomes easier for us to provide personalized guidance. So we take all this information and then we provide customers guidance through a personalized recommendation feed, which is what we are going to be focusing in our talk. In addition to that, we also provide them a cost and credit summary. So as I mentioned, like billing is one of the important areas where we want to help customers understand better. We also provide like third-party exclusive offers. The Tech Hub is where we have like CloudFormation templates and AWS samples, which is created by our incredible SA community that we make it accessible for all the startups. So to understand the Activate console itself, so there are like two big pieces to this. The first one is the Tech Hub. So as I mentioned, this mainly contains technical content, which could be like workshops, blogs, code snippets, GitHub repos, CloudFormation templates. All of these things are like put in a single repository. And the second is the offers that we get from partners that our startups can leverage. So now we saw a couple of areas how we can help startups. So now to understand like why customers want personalization. So in addition to just providing technical resources and third-party offers, startups also want to understand like what are the relevant trainings that they should attend, because sometimes we have like so many number of trainings. Startups sometimes find it overwhelming to discover what might be relevant for them. So getting recommendations around like which events to attend, so that they said like would be helpful. And the other is around networking events, because when we think of building a successful startup, tech stack is just one portion, but how do we connect startups to like different venture capitalists, different accelerators? So that is also something that becomes important. So when we want to provide recommendations, right, and in this case, I want to talk a little bit about like service recommendations itself. So I want to talk about like, what is the complexity with providing this type of recommendation, and let's try to understand with an example. So let's say I am the CTO of an early stage startup, and I want to run my Docker container, right? Today, like there are like more than 10 different ways you can run Docker on AWS. You can run it on EC2, you can run it on Fargate, Lambda. There are like so many different ways. But what startups usually look for is like, what is the best architectural pattern that I should use, which is not only cost effective now, but which benefits me in the long term. So that's the type of recommendation that they want us to provide. And what we want to do is like, since we get inputs from different customers, and we want to take these inputs and provide these service recommendations so that startups can start adopting like different patterns early on, and then that provides beneficial in the long term. So I want to, so based on why customers wanted personalization, so we definitely took that feedback and we built a recommendation system. So this is just the version 1 that I'm going to be talking about. One of the things about Amazon is we have this day one mentality where we built a minimum viable product which meets basic customer criteria. So we built a version 1 of this recommendation system. So in this version 1, so the way it works is, if we want to serve any type of recommendation, first we need to aggregate the content. So the content along with the metadata is all captured to a homegrown content management system. And then the categorization of this content, what is the topic of this content, or whether it is an event, whether it is a technical topic. So all those are done manually today. And this is exactly what we wanted to improve by using machine learning and in particular personalization. So if we want to leverage machine learning and personalization, first we need to understand what are the different attributes of a content and how it affects personalization. So a couple of things. So one is the type of content itself, whether it's an event, a training content, and things like that. So that is a broad category. But in addition to that, there are like several parameters that we look for. For example, like what services this particular content might be relevant for. What broad tech category does it come under? For example, like if this is a content around automating containers, maybe this is something that should come under containers. So these are the type of metadata that we capture. And let's actually look at a concrete example on, for example, if we want to serve recommendation based on localization, like how do we go about it? So let's say like there is a startup in San Francisco, and they want to attend an event around like storage, which is happening in AWS Loft. Most of the time, discovery of these events tends to be like a challenge. So here in this scenario, we want to understand that for what is a startup, like what is their area of interest, where are they located at. So we capture metadata such as like their city, their location, And we also captured the event date as well. So taking all these things into consideration, so we built an ML model which is used to serve the recommendation. So what I'm showing you here is how the UI looks in the final stage. So you can see, like, there is a recommendation feed, and the first event that shows up is the event that is happening in San Francisco. So far, I took you through the high-level overview of what this recommendation system is, what problem that we are trying to solve. I'm going to pass the ball to my colleague Anu, who is going to walk us through the technical stack. So one thing that I want to call out here is, so we won't be focusing too much on the ML development itself, but we'll be focusing on the experimentation and how we tested multiple models before we launch into production. Over to you, Anu.
Thanks, Riyaz. So till now, Riyaz covered how ML-based recommendation model helps startup customers. For the second part, we are going to talk about how these ML models need to be constantly updated and how can these changes be tested in real time. As we all know, it is very unlikely to have a perfect ML model. 10 years from now, the technology will be a lot better. Plus, the user behavior and the traffic pattern keep changing from time to time. So we need to incorporate all these changes in our ML model and make it efficient. So one thing that stands out is when we talk about updating the model or making any changes, that means we are updating the system or making some deployments. And as soon as we talk about deployments, the first thing that comes to mind is risk. Just because there is risk associated to deployment, we should not shy away from it, but rather embrace and make our systems and pipelines efficient and then handle the changes in the most effective manner. In this talk, we are going to discuss about some of the best practices that we have used in our system. But before that, let's see at a high level the different other topics that are covered. At a high level, we'll be talking about the best practices even before starting A/B test, the A/B test itself, and share some of the cool future initiatives that are planned in the pipeline. We use A/B test for determining the winning model, but before that, we have certain checks and balances in place to make sure that the platform is ready for performing the A/B test. The first one is called the AA test. AA test is a precursor to A/B test, and it is also called as platform testing. Here, we are making sure the platform is stable after the deployment without invoking the new feature. So this is just to make sure that the deployment was stable and there are no variables that could affect the validity of the A/B test. Let's see how we perform A/B test in our project. So first, the developers code their changes in development instance. Then that is deployed to a stage instance, a non-production instance, where extensive testing is performed, like the end-to-end health of the application is checked, integration tests are performed, and also using the traffic simulation, stress test is extensively performed as well. Once all these tests have passed, the code is then deployed to the production instance. After deployment, that is where we would configure this AA test. In AA test, as I mentioned, we do not invoke the new feature. So this is configured behind a control and variant. Because the new feature is not invoked, the control and variant would be set to the same value. And in this case, it will be to the existing value. Then the users are divided into groups or cohorts and directed either to the control or variant. Because both of them have the same value, no matter which group the user belongs to or whether they're directed to control or the variant, they should experience the same behavior as well as produce identical KPIs. This is then monitored for 24 hours. The next check what we have in our project is testing with the override. This is where the actual feature would be tested, but only for the testing users, this is exposed. For the general users or the production users, they're directed still to the old behavior. There are two steps to configure this override test. First, the variant is changed to invoke the new feature. Second, the traffic configuration is changed to ensure that only the testing users are allowed to have the new experience. So once this configuration is set up, the testers go verify it in real time, and then after they're comfortable and feel it's working as expected, the live traffic is routed in stages to experience the new feature as well. So this AA test is actually a very neat way to spot check or smoke check new features. Once AA test and override test have passed, that means the platform is ready for performing A/B test in real time. So till now we saw how the platform is ready for testing and we are okay to make the changes, but this is all a happy path scenario. Say there are cases wherein everything passed in stage and the spot check also passed, but then the new feature is not able to scale as per the traffic. So what do we do in this case? The best strategy is to mask the new feature, but should have the least impact to the business or to the user community. So this is where we need to understand that new model is not always better. Change has to prove itself in production in real-time analysis, and that is why we are setting this platform to ensure that the comparison between the old and the new behavior is tested before diverting all the traffic to the users. Let's take a look and see how we can safely mask the new feature in case it doesn't work as expected. There are several ways to do it. I'll just be covering two of them. The first one is using traffic shifting. So all along we built a mechanism wherein we control the feature to be served on how the traffic is directed to one either control or the variant. So in this case what we can do is we can direct 100% of the traffic to the control and nothing to the variant. This automatically masks the new variant. As you can see, it does not involve any complex deployments or any configuration changes. I think we all agree that deployments come with a risk, and here we are mitigating just that. Let's look at the second way of doing it. It is to revert the variant to the old behavior. This is very much similar, or rather it is same as the AA testing that we started with. So in this case, because variant and control are directed to the are configured to have the same value, no matter from which group the users come into, they would be experiencing the same behavior. One thing to understand is that just because the experiment or the deployment was not successful, it doesn't mean we wasted our time. Rather, we were able to gather real-time data insights onto why it was all successful all along but not able to scale in production. So we can use these data points collected and fine-tune our further iterations. So now that we saw some of the checks and balances before performing A/B test, let's take a quick look at what A/B test itself is. A/B test is a mechanism of splitting traffic for drawing real-time inference. Here the users are divided into different groups or cohorts, and funneled into different digital experiences. The different models that have to be tested will already be configured in the system. So depending on the traffic configuration, the groups of users will be directed to one variant or the other, and the KPIs are generated at the end of the session, and they're analyzed to check which variant or the model performs better based on the success criteria mentioned in the conditions. So when we talk about having any component or any system, the first thing that comes to mind is how do we implement it? There are several ways to implement A/B testing. Let's take a look at a few of them. The first one is the homegrown approach. So I think even in our project we thought, okay, we have to build this, so why not build it ourselves? And I think most of you also might have the same thoughts. It is very much possible, but let's take a look at advantages and disadvantages of homegrown system. So in some projects we've seen that homegrown A/B testing mechanism is configured using feature flags. As we all know that building a system from scratch is tedious as well as time consuming. It's not just building, but there is constant maintenance and debugging associated to it as well. And plus the system needs to scale as per the changes in the traffic. If it is unoptimized, then we might end up seeing timeout issues, SQL errors, so on and so forth, which again impacts the business. And third is this A/B testing component is not just the traffic routing mechanism, but it also has the KPI analysis and metrics for inferring the winning model. And that requires knowledge not just in the engineering part of it, but also the teams need to have in-depth knowledge in data science as well as statistics to perform extensive analysis before declaring the result. So what is the other option other than homegrown? The one thing I want to mention is that the advantage, of course, right? I mean, there is some advantage, or there are some cases where homegrown would be the only approach, and that is in systems where it is where the requirement is extremely complicated or it is one-off and not catered by any other way. That is where the teams go with a homegrown approach, because they can modify it or customize as per their use case. So the next option is to use any of the third-party SaaS vendors. The third-party vendors provide a consumer-grade UI. They offer seamless scaling, as well as they provide all the components related to the A/B testing, starting right from the traffic shifting all the way to inferring the winning model. But there are some of the disadvantages as well, which we have noticed in our project as well as heard from other customers. As we all know, it is an extra step and it is tedious to integrate any of the third-party component. And plus, it is hard to configure, maintain, and debug additional component as well in our project. And one more disadvantage that we have heard from the other customers is that in case they are in very tight regulatory requirements, then it is not possible for them to use third-party vendors, because most of them store the KPI data in their infrastructure and process it for inferring the results. What this means is that from the customer perspective, the data moves out of their customer trusted zone as well as it resides outside. And plus, the other disadvantage is that in case the data has to be sliced and diced in a different way, then it is not possible, because usually there is no mechanism to provide the data dump back to the customer. This bottleneck is avoided by actually saving the KPI information before sending it over for analysis. As you can see, it introduces additional duplication as well as duplication of data as well as effort. So let's look at what's the other approach. See, the other approach is to use AWS CloudWatch evidently. Because of the drawbacks listed in the earlier slides, customers were looking for a native AWS service for A/B testing. AWS has the culture of working backwards from the customer. So after collecting enough data points, we realized that there is a way to improve by providing an A/B testing tool. And that is how CloudWatch evidently was launched in the observability stack. CloudWatch evidently offers end-to-end A/B testing component, starting all the way from traffic routing to inferring the winning model. It has tight integration with other AWS services, and not to mention it is a managed service, so it removes the undifferentiated heavy lifting and lets the team work on business critical initiatives. Just like most of the AWS services, this also comes with a pay-as-you-go pricing and offers seamless scaling. Evidently has two different features. They're similar but distinct. The first one is the launch. Launch is where it is used to safely release new features, components, or experience to the users. Here, the developers can expose a small set of traffic to the new feature. And because this evidently is tightly connected to other AWS services like CloudWatch, different alarms can be set up, and automation can be put in place to roll the system back to a stable state in case of anomalies, or it starts producing KPIs which are way off what we expect it to be. But if everything is going well, then the traffic can be dialed up. But after each dial up, it's better to make sure that the system behaves as expected, and that is where all these integration come into place. And to safely dial up the traffic, there are options present as well. The safe dial up will be set up in a scheduled launch section. This is where you can say, hey, I want 10% of the traffic to go to the new feature or the variant on day 1. Monitor, make sure everything is fine, then increase it to 20%, so on and so forth. And then you can go all the way to 100%. It evidently offers up to 5 launch steps. In the print screen, you can see how the traffic goes all the way from 50% to 100% over a period of time. So the next feature that we are going to talk about from evidently is the experimentation. Experimentation is very similar to launch in terms of infrastructure, but it provides a completely different use case. Here, experimentation is used to compare multiple versions of a single feature. The different features to be tested against each other are deployed in production. Then the user community is divided into groups or cohorts, and the traffic is allocated to each of the variant. The users are directed to those variants. After the users are done with their session activity, the generated KPIs are posted, and those KPIs are analyzed using statistics to infer the winning module. One example that I can cite here is our e-commerce website. Here, say we want to modify the checkout button. So we would deploy the changes related to the checkout button. Maybe it's the different size, shape, color. All these variants would be deployed. Users would be directed randomly to one variant or the other. Because in this case, it is a checkout scenario, the appropriate KPI would be to collect the dollar amount checked out, and then after a period of time, collect these data points and analyze. One way to measure the success in this case is to figure out which model had the highest dollar amount checked out and declare that as the winner. Evidently provides different ways to infer the results. It could be any time p-value, confidence interval, and so on. And this experimentation also comes with the scheduled launch feature that we just discussed. Now let's take a look at how it looks on the UI, the comparison part of it. CloudWatch evidently gives you recommendations when A/B testing between variants, and those are in a visual manner. On the slide, you can see the graph, and graph which shows how each of the variant is performing against, how the variants are performing against each other. It also gives you the results at the bottom in a color-coded manner. As you can see, red is worse compared to the different variations that it's tested against, and green is the best performing. One way to save the cost and time while performing experiments is to use any time p-value. When we use that for inferencing the results, we don't have to wait for the experiment to complete. Rather, as and when there is enough data point to infer the results, evidently does it for us. And once the results are there, you can stop the experiment because you already know what the result is. By this, you will be saving not just cost, but also the time. Now that we saw a little bit of what evidently is, let's take a look at how experimentation is set up in our project. So while conducting the experiment, we had 3 variants. The first is the control, second is the treatment or the variant 1, and the third one actually is the treatment 2 or the variant 2. So C stands for control, the first one is treatment 1, and 2 is the treatment 2 in the diagram. The control is the rules engine. This is the V1 of the product, and it is all written in OpenSearch, custom code. There are no ML algorithms associated to it. The reason why we did this is because, again, going back to the day one mentality, we wanted to get the product out to the customers, see how they use it, get their feedback, and then make further changes based on the feedback that we have received. That is the reason we went with the rules engine approach. And that rules engine will be tested against the two different models, ML models. And they are the first one is we're using the popularity score, which is nothing but a weighted session click count. And this is has a mix of, this is again combined, not just the session count, it has a mix of session count as well as the rules defined in the rules engine. And treatment 2 is a completely popularity score. This is a very aggressive treatment. It's not viable in the long run. We'll talk a little bit more into it on why we even have it in the first place. So now that we know that what these three different models that are compared against each other, let's quickly take a look at the architecture diagram. On the slide, you can see the complete Activate Console architecture diagram. We will not be covering all these pieces. We'll just be focusing on the A/B testing component. And as you know, A/B testing can be divided into two pieces, traffic splitting and metric analysis. So for the traffic splitting part of it, we are using Evidently in our project. And in Evidently, we have three models configured. That is the control, model 1 and model 2. Whenever a user logs into Evidently, it makes an API call, and then it retrieves which variant it needs to be directed to. And for this experimentation part, we have the control set to 50%, model 1 set to 30%, and model 2 set to receive 20% of the traffic. So depending on the flag it receives from the Evidently on which variant it should be directed to, there is a switch case statement in the application which actually does the routing of the model, and then ultimately the users receive the results of the recommendation engine based on which model it catered to. So this was the traffic splitting part. Now coming to the metric and analysis part. We do not use Evidently for now for metric analysis. The reason is again the same day one mentality. We had a custom data pipeline in place. We are just using that for now, so that we always make changes, small changes over a period of time. We don't have to touch all of the application at once. So having this mentality, we are still using the custom data pipeline, but then there are plans to move this to Evidently as well in the near future. As you can see, Evidently has a lot of different components, but they can be used, only the pieces that you want can be used. You don't have to use everything in one go. You just use what you want, and then you pay for that price. And in our case, we have a mix of Evidently and homegrown. So similarly, you can have a mix of Evidently or third party, homegrown, third party, any combination of those. And plus this A/B testing, as you can see, it's kind of like two separate things. It separates the data science as well as the platform. So it's easy to check one over the other and make sure which piece is not working. So we ran this experiment for 30 days, and happy to say that we had a successful result. And this is the result that we achieved. As you can see, the uplift is very high. So usually when you look at it, you'll be like, is that even true? Why is the uplift so high? We don't see that usually in our projects. The reason is because the very first version was all in custom code, open search, no ML. And the second version is ML based. That is the reason between the version 1 and version 2, you see a very high uplift. And usually we have seen in projects that the first change is the uplift is high, but then subsequently it gets hard to achieve this kind of uplift. I would say rather it's extremely difficult. And one thing to notice is that when you look at the graph, the red one is the control, the green is the mix of popularity score and the rules engine, and the third one is just the popularity score. I mentioned that the T2 version, the popularity score is very aggressive. We don't want to have it running in the long run. This is something like there's a patient who's having some problem, you give a medicine and it treats the problem for short term, but then ultimately the patient is going to die. We don't want all those things happening. So that is the, and why we say this is aggressive is because just having the click count, it's not really, does not add value to the business. If the title is catchy or if there's any clickbait, then it increases the count, but not add real value. That's the reason even though T2 looks like the winner, we will not be going with T2, but with T1. So now you might be wondering, why do they even have this T2 in the first place if they're not considering it? It is because as per our hypothesis, the T1 should lie between the control and T2, and it is used as a roof to find the maximum value that can be accomplished. And as per the results, the hypothesis what we had in mind is correct. So for our case, T1 would be the winning model. Now I'll have Riaz come up on stage and walk us through some of the future initiatives in place.
Thank you, Anu. That was great. So we definitely learned a lot from this project, not only about building ML models, but how to experiment and launch them in production. So we definitely want to use these learnings for our future initiatives. There are several projects that we are working on to improve the customer experience. The first one is improving startup onboarding experience. So here we want to use machine learning to automate sign-up process for startups, so that they can sign up and get credits instantly. So that's one area we are leveraging ML. The other we talked about is using machine learning to provide intelligent architecture recommendations. So whether a customer should use RDS versus DynamoDB versus Neptune, like all these types of recommendations. So we want to provide using machine learning. So that's another project. And the last one is we also want to encourage like startups and founders to come together, collaborate as a community and build on AWS. So that is also a startup community-based project that we are also working on. So with that, I want to wrap up today's session. Thanks so much for listening to us. I hope the insights that we shared today was helpful, and I can't wait to see how you apply to your projects. If you have any questions, both me and Anu will be outside the room. And you can also reach us via the email as well. Thanks so much. Have a nice day.